Hey guys, today we're going to be talking about even and odd functions again. So even and odd functions we did talk about already when we were talking about graphs, and we talked that if you come over here, even function is when you reflect it, when it's exactly the same, if you reflect it through the y-axis. So in other words, if you fold it along this line, it's the same on this side as it is on this side. Looks exactly the same. That's an even function. Okay, an odd function is when you reflect it through the through the origin. So when you reflect something through the origin, it looks like this, exactly like starts down from infinity, little bump there, and goes up. If you then take it and flip it around, it looks exactly the same. So you can do that with your paper, but that's what an odd function is. So just like with this one, if you start low, there it's exactly the same the other way. Alrighty. So if you remember from last year, when you reflected something through the y-axis, you changed the sign of the x. If you reflected something through the origin, you changed both of them. And that's really all we're going to be doing today, but we're going to be doing it with functions. So the way that this works, so with an even function, when you reflect it through the y-axis, when you negate the x, the function stays the same. When you reflect it through the origin, when you negate the x, every term changes its sign. So that's all that means. It's the same thing as what you did last year, but cooler because it's with functions. All right, that's all that means. I just explained that here. So when you plug in negative x, the y value remains exactly the same. The function is exactly the same. So f of x equals f of negative x. And when you come down here, an odd function, when you plug in negative x, every sign, all the signs of the function changes. So that's all we're doing. But we're doing this algebraically. So you can't just plug it into your calculator, flip it over, and say if it's even or odd. You actually have to show algebraically, meaning with x's and all their numbers and stuff, to determine if something's odd, even, or neither. So here's the procedure. You plug in negative x, and do whatever math comes up. If the image is exactly the same, it's even. Every sign changes, it's odd. Nothing is, nothing like those two things happen, then it's neither. So let's try it for this one. We want to determine if this is even, odd, or neither. Okay, so what we do, plug negative x in. So we plug negative x in, and it has to be in parentheses like this. Okay, so when I raise anything to the fourth power, it's negative x times negative x times negative x times negative x. That's an even number, so that's just the same. That's x to the fourth. If I plug negative x squared, that's easier to see with this one, is just negative x times negative x. And negative x, so that would just be positive x squared. So this is just positive x squared plus 3. All right, so then we look at f of negative x. Well, how does it compare to the original? So you look at this one, you look at this one. X to the fourth is the same. Negative 2x squared is the same. And 3 is the same. Since all of them are the same, that means it's the same as the original. So that means this is an even function. Done. That's it. That's all there is to it. So if we, the next one, let's make it a little bigger. Same deal. Is this even, odd, or neither? Plug negative x in for x. So it has to look like this. Wherever there's an x, you put parentheses. Negative x to the third. So if you need to write it out, it's negative x times negative x times negative x. These two make a positive x squared, but this one's still negative x. So when we do put this all together, it's negative x cubed. The basic idea is that if the exponent that you're raising it to is odd, which this one is, the sign remains constant. So if it's negative, it's going to be negative when you cube it. And whenever it's an even exponent, like a 2 or a 4 or a 6, it's always going to end up being positive. What's in parentheses is always going to be positive. So then 6 times negative x is just negative 6x. Because this is a negative 1. 6 times negative 1 is negative 6. So f of negative x looks like this. Now let's compare it to the original. So this is the original. This is the one we have. X cubed is positive. Here, x cubed is negative. Sign change. Okay? Oh, that's sing change. Yeah, awesome. So sign change. Good. So here, this is a positive 6x. This is a negative 6x. This is another sign change. Both of them, all of the terms, are completely opposite. Their signs are completely opposite. That makes this an odd function because f of negative x is equal to the same thing as if I plugged negative and I just changed all the signs of the function. That's what this means. It means change all of the signs of the function. Alrighty? And then the last one, take a guess what's going to happen with this one. So we plug negative x in. Negative x to the fourth plus 2 negative x cubed minus 3. So like we said before, this is an even exponent. So whatever's inside parentheses, it's going to be positive. So that's x to the fourth. This one, this is an odd exponent. So we always are left over with one extra negative. So this is going to be 2 times negative x to the third. So it's negative 2x to the third minus 3. So with this one, if we compare this one and this one, how do they compare? And when we say compare, we're really just looking at the signs. So the sign of x to the fourth stays the same. The sign of this one and this one changes, and this one and this one stays the same. So same change same. This is neither then. They have to all be the same, or they have to all change for them to be positive, to be even or odd. So that's it. Plug in negative x, see what you get. Have a great day.